Assalamualaikum and hello guys. Today I'll present my FRP2 project presentation, which is Zerahood. Zerahood stands for Zera is my gamer tag name, and the hood is heads-up display. So what my project is a universal navigation device for motorcycle helmet, which can be attached to any kinds of motorcycle helmet, and it displays only navigation data, nothing other than that, which is transferred via Bluetooth from the mobile application that I created. So these are some examples of heads-up display that has been created for a vehicle and also for an aircraft. So we take these two inspiration and then create a heads-up display for a motorcycle as well. So first of all, I would like to talk about the reason behind this project. It is due to the fact that nowadays, the food delivery services, which are from techpreneurs, like Foodpanda, GrabFood, and everything, they utilize Google Map or Waze on their phone, which is attached on the handlebar of their motorcycle. And this is considered dangerous, as the phone that displays their navigation route is not on their field of vision, so they have to keep on looking up and down from time to time to reconfirm whether the direction that they are going is on the right direction. And this action may cause accidents from small ones to big ones. And then next would be the proposed solution, which is to how I would tackle this issue is to first of all develop the universal heads-up display, which can be across multiple motorcycle helmet, because I don't want to create a smart helmet. I want to create a smart device that can be used in any kinds of helmet. They can just attach it and then they have the heads-up display. So methodology that I use in order to complete this project is a prototyping model, which is considered agile. It is also one of the most commonly used methodology, even in tech companies where like startups or even like those big ones. It is due to the working where you can do a parallel development and testing. So the first of all on my project methodology is my requirement engineering, where I would collect all the necessary data and function that is needed from my colleague who drives a motorcycle, and also create a Google form where we can pull this feedback. And then from there, we design the UI, UX, and the flow of the application, and then the flow of the data. And then we proceed to creating the prototype. And then concurrently with the live testing, after everything is working seamlessly together, we provide the final product. So how this thing works is it's very simple. You download the mobile application, you register, log in, and then once you are logged in, you are being prompted for your GPS location to get your current location, and also your Bluetooth so that you can connect it to hardware device. So you connect your mobile, connect to the device via Bluetooth. The mobile, you can search for the places that you want to go, or find places to go, and then you just hit the arrow button, and then it will show you the navigation route. After it shows you the navigation route, you have to press again to reconfirm whether you really want to go to that place. And after that, once you press start riding, it will display the navigation information like you see on Google Maps or Waze, like in 500 meters turn left, in 200 meters turn right, things like that. This is how the mobile application works. So I will now go into under the tools that I use before we get into the live demo. So these are the software I use in order to build this product, which is the Arduino IDE is to code our Arduino product, and then the Android Studio is for testing emulator, and also the React Native for developing the mobile application. And then the Visual Studio Code is for me to write the code inside. The Firebase, previously I wanted to use AWS, but I move on with Firebase because it's easier to implement. We use the authentication and storage to store the bookmark location and also the user details. And then the circuit IO is being used to design the schematics. And then move on to the hardware. With a blueprint that's already set and workable, we can make a cost which is around less than 100 ringgit, which is affordable for any kinds of motorcyclists. So we are covered the objective, the introduction, why I choose to do this project, and everything. So we move on to the live product. Presenting the live demo of my FIP project. Okay, over here, if you can see this is the OLED display that will display the navigation data to the users, and then this will be it's quite big because of the sizing, but this is the Bluetooth module. You can see if it's connected or not later when you see the light went off, and then this is the microcontroller. I'll be charging this on power bank because I didn't set up for a battery. So first we'll go through on the mobile application. We will open. I'm doing the mobile. I'm screen recording the mobile application as well. So first we will create our account in the mobile app. We are required to log in under email and the username. So we first create an account, Lucian, and Lucian 036. Then hit sign up. And then once we sign up, we'll be redirected to the login page. And then we hit Prinzera. We log in. Inside the login, we'll be prompted with a Bluetooth connection and GPS. And then we just enable our device location and also the Bluetooth device, which is already open on top. And then we can press to connect to device, but first we have to on our device. Let's connect to Bluetooth. If you connect to Bluetooth, you can see on the screen, this is the display, welcome to Zerahood, and then the Bluetooth device is blinking, means it's not connected. So from the mobile app, we will press to connect to device. And you can see the Bluetooth asking for pairing, and 4. Then you can see after the screen finish load, it is connected to Bluetooth, and then the thing is finished. And then we can search. So let's say right now I'm in Mutiara. I want to go to Nepal Cyberjaya. And once we search, we can bookmark it. So to save for the next time we want to go, so we press location bookmark, and then we go to the area, and then it will show us the route from here to Nepal. This is a long route, I think. Okay, but it's fine. And then we can hit start. We'll start riding, and then the navigation data in 1.4 kilometers head northwest on Persiaran Sepang will be shown on the heads-up display. Hold on, let me. Yeah. Okay, and now once we reach the location, certain parts of the location after 1.7 kilometers, which is somewhere here, then we will turn the navigation to another place. Okay, so we stop at the side so that we can show you that we are at the last direction in order to get to the pulse, which is in 200 meters. And then once we are done, then we are welcome to Zerahood. It's back into the place that we are in. And also we showed that we bookmarked the place just now, so it's underneath our safe location. So we can just straight away directly go to instead of searching for the location, you can just utilize the book. Now I'm gonna explain about my poster, but we have gone through previously how it works, so I'm just gonna summarize it. The introduction is from the mobile app to the Google Map API, send the navigation data to the helmet and display it. The aim and objective I've mentioned before. Same goes for the methodology, and the technology used are the hardware and software that I've specified. And the problem statement is as previously, which was the food delivery services and then the dangers of it. And the results are some of the pictures of the software and hardware design. Though I didn't touch in future works earlier in the video, so for future works and suggestion, I'm going to add a water resistant enhancement so they can use this device while it's raining. And also I'm gonna improve the size of the display and also the clarity of the information display, just in case people with different vision, like those that wear spectacles, can be able to see the display. And also find another alternative to power the device instead of using the power bank, and have a smaller microcontroller instead of Arduino, because right now it is a huge chunk of the controller beside the helmet. I hope you guys enjoy watching my video, and thanks for watching.